Okay, should be recording. Hi guys, it's me, Louis. Also I have my lovely fingernails here today. Ooh. I'm here to help with the tutorial stuff because I heard a lot of you guys having trouble on it, so I'm here to help. I'm gonna work out stuff on here just to make things easier, just so I'm writing stuff down so it's easier for you guys to follow along. If I just show you a lot of text at once, it's not very useful. Can I zoom in with this? Oh, I think I can. Did that work? Oh, look at that. Oh, what fun. I think that works. Zoom in a little more, just so, because I assume you guys are going to look at this on mobile, so I got to be careful. All right, so let's go through this. So you have a function here. U is equal to x cubed y squared. So this is the utility function. It's also known as the indifference curve, so just if you guys get confused. Now, for A, you are asked to find what the MRS is, right? Now, the MRS is not like a single value, okay? It's not like 1 or -2 or anything like that. It is the gradient of the indifference function, and because that gradient is always changing, it's an MRS function, not a MRS value per se. It does say marginal rate of substitution, but well, that's why we're talking about rate, okay? We're not talking about value, we're talking about how it's changing. So, to find the gradient of this function here, some of you might be familiar with this. We're going to do implicit differentiation from A-level. I can't remember if it was in A-level or further maths, because I did both. But maybe you've covered this. So, let's start with just assigning u some random value. We could leave literally anything, it doesn't matter. So I'm going to call u 50, and we have x cubed and y squared. Now we have to differentiate with this, okay? And we are looking for, well, first of all, let's think of our graph at the start. So, let me put this to the side for a second. So, what the question is telling us at the start is that we have two things. We've got number of free hours, which is we're going to represent as t, and then we've got consumption, which we're going to represent as y, right? Now let me just check the question. I've got it up here. Let's see. Individual has a utility function. Yep, that should be fine. The maximum hours she can work in a day is 24. All right. So we're assuming that we've got 24 here and 0 here in time, and then it's going to go sort of like this. So she can just have 24 hours of free time, and then she can just not work and get no consumption, or she can work as much as she can, having no free time, and get max consumption. So that's sort of how it looks. Now, the u, x cubed y squared, is going to look something like that, okay? And we, well, inevitably you'll see, we want to find where this curve here intersects this line, okay? So, back to what we've got here. Remember, we've got to find, oh, sorry, I forgot to mention. When we're trying to find the optimal bundle here, as you guys probably remember from chapter 3, we need to find a point on the indifference curve and the budget constraint where the gradients match. I would say that would probably be something here, but remember, it needs to match. So we're going to continue with this, and just hopefully we should get it. Okay, I'll keep on referencing this as we go along. Okay, so back to what we had before. So we have 50. It looks like so, but it's 50. We're going to implicit differentiate this, okay? Now what we're aiming for at the end is dy over dt, okay? So dy over dt, we're aiming for this. Because this, okay, if we think about this one again, okay, dy over dt would be the same as dy over dx in this case, yeah? Kind of the same thing, yeah? All right. So, how are we going to get that? Well, it's implicitly differentiated, so it's a bit trickier. Okay, but pretty much what we're going to do is we're going to differentiate every single thing in this function by t. Okay, so let's start at the beginning. 50 just differentiated just reduces to 0. Fairly easy. Okay, after all, any constant being differentiated reduces to 0. For x and y, now you can tell that these two functions are being multiplied together. So this means product rule we're going to have to use. Okay, so I'm going to do derivative of x times y. So that's going to be 3x squared times y squared. Yeah. Hopefully everyone's following along so far. And then I'm going to add the next one. So now I have to differentiate y. Now, the thing is here, because we are differentiating y now with respect to t, okay, we're going to actually have to put that in there. Because I would say that we were doing dx dt here. So we're going to do differentiating dy dt on the end of it. Some of you might remember this from when you're differentiating in A-level. Okay, you differentiate with respect to another variable, and then with other variables you're going to put that one on top of dt or whatever. So we're going to keep x the same, and we're going to differentiate y, but remember you have to add on dy dt, because it's implicit differentiation, okay? We need to include this, alright? Because we were differentiating dx dt before, okay? Because we were differentiating relative to x. So we have to include this for y. Okay, I won't explain implicit differentiation too much because it'll take too long, but we're going to move on from here. If we rearrange this, we get minus x cubed 2y dy dt equals 3x squared y squared. Now if we divide by this section of the function on both sides, we inevitably get a formula for dy dt. This is going to be 3x squared y squared over minus x cubed 2y. Simplifying this down, we cut out the y's and the power up there, and we cut out that x and the power here, and then we end up with minus 3y over 2x. Now let me just check that that matches what I got. Yes. Now, I slightly changed this to make this a little easier, okay? Just think of x and t as interchangeable, okay? So it should technically be t here, it should be t here, it should be t there, it should be t, 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 and t. Okay, sorry about that, guys. Sorry, force of habit, I kind of go for x's quickly. Okay, so now, let's get off. Yeah! So I'm looking at the screen to check the camera feed, just to check it's already working. So now we know that the MRS function, or essentially dy dt, is going to equal minus 3y over 2t. We now know that any gradient here, okay, is going to depend on this line, and that gradient, which I'm just going to quickly define as m, is going to be minus 3y over 2t. Okay, now, let's look at B. Okay, so B, let me just check what it says. If the price of consumption is 2 for every unit of consumption, and the wage is 2 for every hour worked, what is the choice of hours of work and consumption per day? I can't read. Oh, God. How long is this recording, by the way? I just don't want to make it too long. 7 minutes. Ooh. Hopefully you guys have patience. Oh, hold on. Yeah. All right. So we have here a cost of 2 for consumption and 2 for wages. Well, technically 2 for wage, yeah. So, think of it like this, okay? We're going to have a max income, okay? Now, the max income is going to be wages times by the maximum number of hours, 24, right? So, working 24 hours for £2 an hour would be 48. So, we're going to equate that to our income, okay? Now, we're also going to equal, well, 2t here, because remember, with time, that's going to increase, right? So the bigger the time is, that's how it's going to work. And this is also going to be plus 2y, okay? This means the sum of consumption and time taken off is going to equal 48, okay? So say we work, for example, just on this graph. Let's say we've got 24, 0, and this is going to be 24 up here. Remember, this is 24 because consumption costs 2. So we can only have max 24 consumption, because 48 equals 2y, simplifies to y equals 24. Okay, say we had something like this, where we worked 8 hours? Yeah, sure. So we're going to have 16 hours of free time, and then using this equation, well, if we have 16 hours of free time, so that's going to be 32, then our consumption is going to be 48 minus 32, which is 16, and then divide by 2, so that's going to be 8. Alright? That's generally how our equation works, okay? So we've got now this lovely equation for our feasible frontier, okay? This is what we can have, all right? And an easier way of representing this is in a form you guys might be familiar with. It's either y equals ax plus b or y equals mx plus c, whatever you guys use, okay? And we're going to just rearrange this, all right? I'll leave you guys to do that. You can probably do that by yourself. But what we end up with, or what you should end up with, is y is equal to minus x plus 24. I know that graph may have made it obvious, but just bear with me. Okay? So, we've got that budget constraint. Now, this is the tricky thing now. Alright? Normally, we have information about like what the utility is here. In this case, we don't. Alright? We have the feasible frontier for B. Okay? And we have a utility curve with an undefined utility. Okay, we don't know what that is. And it's going to be x cubed and y squared. We also have the MRS, okay, which is going to be dy dt, which is equal to minus, let me just double check I'm getting this right, yeah, minus 3t. Ah, hold on, forgot, it's t. It's t. Must remember that it's t. So, how are we going to do this? Well, remember how I said, when we've got an indifference curve, it has to be tangent to the budget line, right? Well, what's the gradient of the budget line? Here, as we can tell from our little gradient here, minus 1, right? So, we know that the gradient of the budget line is minus 1, so the gradient of the indifference line must also be minus 1, meaning this has to equal minus 1, yeah? So, let's solve for these y's and t's, yeah? So, if the gradient has to be minus 1, then this must be true. Okay, we've got minuses on both sides, we can factor them out. Alright, and then I'm going to multiply by 2t on each side. This gives me 3y equals 2t, or if I want to simplify it further, y is equal to 2 over 3t. Now what does this mean? Okay, it's not particularly obvious like what to do with this, okay? Well, this line now represents all the possible, points on the indifference curve that have a gradient of minus 1, right? So we use the function, gradient, all the ones that have minus 1, they're going to lie on this line. Okay? So, we know two things now about our point of utility. We know that it has to lie on the budget curve. We know that it has to lie on this. So, these two lines are going to intersect. So, we just need to solve for that point where they intersect. Alright? So, this should be fairly easy from here. I substituted this into the next equation. So, I put this in here. Give me a moment here. And that's going to equal minus t plus 24 from our top equation up here. Solving for this, you get 5 over 3t, which is equal to 24. And then you get t, which I believe, if my memory serves me correctly, hold on, 72 divided by 5. Yeah, that's 14.4. Okay, so the optimal amount of time that you can spend, your free time, is 14.4 hours, okay? Which means the time you're spending working is 9.6 hours. Ugh, how horrible. Anyways, so we've got can't move my pen, I'm looking up at the screen. So we've got 14.4 hours. Now, if we just backtrack, put this back in here, 2/3 of t is equal to y, right? So 2/3 of this is going to be y is equal to 9.6. And there we go. So, for B, the answer for the optimal bundle, okay, so the choice, let me just read this over again. The price of consumption, what is the choice of hours of work and consumption in a given day? So this is what it's going to be. So 14.4 and 9.6. All right. Oh, I should probably do a disclaimer in the middle of this. I'm not perfect, okay? So this is my calculation, okay? This is what I've got, all right? Obviously, ask your tutors. I'm not like the final authority on this sort of stuff. I mean, like, I've done this quite a few times, so I have a fair bit of confidence, but I'm not the final authority, so check, okay? Double check. All right, we're going to continue. So with C, it's a slightly different one. So let's think about our max income. So it says now, what will be the optimal choice of price of consumption, but wages increase to 4? Intriguing. Okay, I'm pulling out all the stops here. So wages increase to 4 means that our income is going to be 96, because 4 times 24 hours, 96. Okay. This also means we're going to have 4 times t. Aha, I remembered. Because that's going to be the time, which is in addition to consumption, because consumption stays constant. Okay. So this is going to be our feasible frontier for C. Now, rearranging this for y equals mx plus c, I know you guys can do it, but I'm just going to quickly do it for you. It's going to be y is equal to minus 2t plus 48. All right? So your max consumption here is 48. That's the maximum of y, because you can see here that 96 divided by 2 is just going to be 48. And obviously your max hours are still at 24 because they can't really increase, can they? Okay, so we've got a similar thing here. The MRS is still staying the same. That good old dy over dt is still minus 3 over 2t. You know, the indifference curve doesn't change what it is. Okay, so we're not going to change that. Okay, now we also have to find the same thing here. Now, we now know for this one that the gradient is negative 2. So we're going to equate this again to negative 2. This will give us eventually, so we've got 3y over 2t equals negative, equals 2. Oh, I've just taken out the minuses. We multiply to get fucking... Yes, that's the police. They're coming to arrest me for my maths tactics. You know? God, that was a terrible joke. Anyway, simplifying this, you get 4 over 3t. So we know it's going to lie on this line, and we know it's going to lie on that line as well. So we're going to do the same thing as before. I'm going to do 4 over 3t equals negative 2t plus 48. Okay, this gives me, that's going to be 6, so that's 10t over 3 is equal to 48. And that should give you for t 14.4 again. Huzzah! Now for y, okay, let you guys work this out, but just to skip through, y is going to be 19.2. Now, let's compare with this. So we had b, alright, we had a t of 14.4 and y of 9.6, and then we had a t of 14.4 and 19.2. So we can see between b and c, only the consumption is going to increase. You're not going to change your time. This is what the preferences dictate in this case. The only thing that happens is you double your consumption as a response to the doubling of wages. Seems logical, right? Okay. So now that we've got that idea, we're going to draw. All right. So now let's go with both of our lines. Okay. Now, for our consumption, y, I'm going to label this consumption. What fun. And t over here, which is hours free. They're both obviously going to start around here at 24. As we can see from B, does this show it? Does it show it? Did it? Did I show it on another thing? There it is. Sorry, I've got lots of pieces of paper. For B, the equation was this. So the max consumption here is 24, remember, because 2y divided by 2y equals 48. That's the max consumption. Divided by 2, it's 24. So we're going to put 24 here. The max consumption for this one, again, remember to divide by 2 for the price of consumption. It's going to be 48. So we're going to put 48 up here. Both of these have got to hit 24. Do I have a ruler anywhere? No. Okay, this is going to be a sketch. You guys do it in more detail. Okay. This is just sort of showing you how to do it. All right. So we've got these two feasible frontiers. Okay, this is for B, and this is for C. All right. Now we've got two solutions here. Okay, we've got B here. Let me just write down C to make it easier for you guys to see. 14.4 and 19.2. So we know that this is the optimal bundle here. I'm going to say 14.4 is around here. Okay, and then we're just going to draw a dotted line up. These are going to be the optimal bundles for each of these. Okay. Alright, cool. So we have 14.4 hours. Okay, this one is going to be, I'm just going to draw a dotted line along, 9.6, and this one is going to be, oh, I didn't really line it up. Oh, who cares? It's, again, you guys do it in detail, I do sketches, okay? So these are our two optimal bundles, okay, but we're going to have to draw our lines, okay? Now, also, I prefer if you used graphing software to do this. I've got graphing software called GeoGebra, so it's G-E-O-G-B-R-A, yeah, that was correct. No, G-E-B-R-A. Jesus Christ, I'll just write it as GeoGebra. It's very useful for graphing, especially stuff like this. But yeah, that's how we do it. Now, so it says draw a graph, okay, and show the effect of income substitution. So we can tell here that it's going to increase, okay? You're going to increase your consumption, and that's it, okay? That's all you're going to do. We also may want to draw a utility curve, so it's going to look something like this for C, and something like that for B. Okay, hopefully that should have helped. Okay, so that's D there. So this is good old D. All right. Oh God, I've made a sex joke. Sorry. All right. So that's our sort of thing here. I'm going to put that aside because I think that might be useful for you guys to see. Okay. Actually, I think we could just discuss E. No. Let's draw out E. Okay. So E is a bit tricky because it's stating what if there's a maximum legal work limit. Now, what I thought to start was you could. It's like you have to have 8 hours free off work or something like that. But what it's saying is that what if you could only work 8 hours? Okay. So let's think about the budget constraint here. First of all, the max hours is 8. Okay. So I will define it here. It's 8 here. Okay. Therefore, so for the first one, we remember max consumption was at 24 for the first line. So it's going to be 8 again. All right. Because we've reduced it. It's 24, now it's 8. The other one's just going to be 8.16. So we have massively reduced the budget lines here because, as you can see, it's 24 before. The gradients are going to stay the same. Remember, the price of consumption and the wages haven't changed. It's just the hours. So this is just the possible things that you could get here, right? I mean, in the top one, with 24 hours of work, 48 units of consumption is fine. Because remember, you've got 4 times 24, 96, divided by 2, 48. Now you've only got 8 times 4, which is going to be 62, divided by 2, 16. All right. Now here, we can see that the indifference curves that we previously used are way further out. They're not even going to touch. So we're going to have to bring our indifference curves in. Okay? So what's going to happen? Well, everyone's budgets are going to come back in, and we're going to get a lower number. It's going to be something around here. Now, I could probably do that. Yeah, I could probably tell you guys how to do that. I could calculate this now, but I'm honestly not bothered. What would happen in B and C if there was a maximum legal work limit of it? I'm just making sure I've answered the question correctly for you guys. Yeah. So all the people's budget constraints are going to move down like this, okay? Which is going to be difficult for quite a few people. Let me just check what I wrote here. Yeah. So remember, the trade-off's going to be the same, okay? People's trade-offs are going to be exactly the same as before, all right? It's just that they have to reduce their consumption and obviously their hours. They're going to have to reduce it. Okay, so that's E. I probably better just talk about stuff for D. Where's the pen lid? There it is. Let me just bring that back up. Hooray! Just give you guys a good look at that. Just keep it there in case you guys want to take a picture of the screen right now. Okay, I'm going to move the camera to myself. Hello? Oh God, I'm upside down. Hold on. I'm zoomed in. Hold on. Reset that. Yes, please. Oh God. Hello. Right. Just move that camera down. Oh, this is just so annoying. There we go. Hi. I'm Louis. I'm the person you've been hearing from. And I've probably also filled your WhatsApp with too many notifications. Sorry about that. Also, I can't work with the camera. Right. So for E, obviously I don't... no, for F, sorry. For F, obviously I don't need to write anything down. It says, discuss the general implications of a legal work limited life. Okay? So, what I got, again, don't take my words as gospel, please. What I got, I'm just going to read it. So, illegal work limits can hinder a population's productive potential. So, people are going to be... there's less productivity, obviously, because you've got less people working as many hours as before. So, you've basically got... People have got the same jobs, apparently. They've got reduced wages, which is a major thing. And they are also working less. This is a significant thing, especially for industries which require high productivity consistently. Okay, so for industries in manufacturing, if people are working shorter hours, you can't put up as much out. So all that is going to sort of grind to a halt. So your productive potential is going to go sort of into the floor. You've also got an impact on welfare. Now, impact on welfare is going to be slightly different because people have more time to pursue their hobbies. Of course, they will have less money to do that, but they will have more free time to do other stuff. Okay, so that's quite a good welfare thing. You don't limit people in that aspect. Okay. Now, I'd like to just go back to that. Hold on, can I vertically flip it? Yeah. Okay. And let's just quickly zoom in. No, that's autofocus. Why did I just put on autofocus, please? Thank you. Zoom in. Zoom in. There it is. Okay. Will it just do that? Yeah. But you can see here that this budget constraint is hitting 14.4 hours. This person is working 9.6 hours a day, which means it would be illegal to do such a thing. Okay? So what you would do here, okay, is everything would have to kind of go here. Okay? We showed what happened there already. Okay? So that's sort of what's... Hello, again. Vertical... There it is. Okay. So people are obviously going to have less wages, less ability to consume, as we've seen in our graph. Here, you've got less ability to consume. Oh, for God's sake. Less ability to consume, as you can see. Okay. Again, I'm horizontally flipped. There we go. So yeah, people are just generally going to be worse off. Now, there's an interesting effect. I'm just trying to read what I wrote here. Yeah, employers might oppose this because they're losing out on the benefits of labour. But they do have to pay a lesser wage, so it depends on what employers value more. Do they value the work hours their employees put in, or do they value the money that the employees are worth? Okay? If it's the work hours, then it would be pretty terrible for them. Okay? If it's the money, then they probably won't care that much because, oh, it's a reduction in wages. Hooray! And they probably won't care much about productivity if they don't care about hours. So I also said here the government could artificially deflate prices to put things at the same price level, which is possible. Okay, if you've deflated prices, then everything would kind of just spring back to what it was before, but we'd have people working less hours, so it's possible. And we could also increase costs to producers. So, for example, if people's wages sink because they're working less hours, we could increase their wages so they can still afford the same amount on the same amount of hours. Okay, obviously employers don't like this because that's extra stuff for them, but hopefully that'll help. Okay, I've just realised this has gone on for half an hour, so sorry. I know this is long. Okay. Tell you what, I will post this video and I will also post the worksheet that I did. Okay, just so you guys can see what I did and then listen to me explain it. Okay, hopefully that's all good. I hope this actually uploads to the WhatsApp chat because it's probably going to be a big file. But yeah, cool. See ya.